start with a quick apology that I have a cold, so if you can't understand me or anything, just like raise your hand, shout, wave, and I will repeat myself. But yeah, today's agenda, what we're going to talk about, first I'll introduce a little bit about Braze, the place that I work. We'll talk about what it does and kind of how our system is architected and how all the pieces fit together. Then we'll talk about how we observe how Braze works and how how there's a services bias in modern operational tooling. So whether it's Datadog or some other type of operational observability tools, there's definitely a bias towards services. We'll look at the good and the bad there. Then we'll talk about breaking down a monolith without refactoring. So how do you look at a monolith through the lens of services or of service-oriented architecture? And we'll spend a good amount of time going through an example application, so some actual Python code for something that I wrote that actually takes this sort of theory and turns it into practice. So quick thing. So I'm Zach McCormick, senior staff engineer at Braze. I've been there for about 5.5 years now. Really worked on like a good portion of it, but mostly on sort of the architecture that allows us to scale to sending billions of messages every day. So we send billions of messages. What does that mean? If you haven't heard of Braze, Braze is it's a SaaS platform in the sort of marketing automation space, and we power customer-centric interactions between consumers and brands in real time. So that means powering the experiences such that let's say you walk into a store and then you walk out and you've got the app for that store on your phone, and a couple days later, you get a push notification that says, hey, like remember coming to the store or looking at this item or something, here's a 10% off coupon for that. So really that like high level of personalization, and we do that across lots of different channels. We do it across time with a lot of different technologies, sort of a multi-dimensional thing. So major features, multi-channel messaging, sort of table stakes. We have a product called Canvas that allows you to build workflows that happen across a period of time. So if you think about the last time that you got 3 or 4 emails over a course of several days reminding you like, hey, you forgot that thing in your cart, powers that sort of experience. And along with that, we've got a bunch of data ingestion tools. So whether it's getting data from the way that you're using an application, maybe you're on Seamless or Grubhub or something, and you ordered some food, that sort of data, but also potentially CRM systems or ERP systems as well, where you may be feeding other information in about your users. And last, we have a product to be able to ship a lot of that data back out to your data warehouse or to other partners that we call currents. So I stole this one from our sales deck, so you get to see if I'm any good at this. Braze uses a vertically integrated stack design. This is kind of how we think of it, and it's got these streaming feedback loops, and that helps us deliver messaging across channels at the right time. So the sort of stack that we think about, it starts from the top and it flows down. It starts with data ingestion. So I just mentioned, we've got SDKs for different devices, and those could be your typical messaging devices, like an iPhone or an Android phone, iPad, something like that. It could also be one of our SDKs that are primarily data collection. So, we support a lot of things there. We support Roku, we support the Unity game engine, several different things, as well as like integrations and APIs where you may be bringing in data from other systems. And it goes through phases of classification orchestration where we figure out, okay, so the user did this thing. Does that mean anything? Should we be sending any messages? Should we be moving users through these canvases when they do those things? And then it kind of goes to the end where we personalize the message. So it's a lot more complex than just your simple, hello, first name, last name, but really, highly personalized. And especially with kind of the world of AI and all the recent advances there, we've started to see, even more layers of personalization being added. Definitely check out our website if you're interested in that sort of stuff. I know there's a big hit at the keynote here as well today. And then action. So it ends with the actual channel that we reach out to you on. So it could be in-app messages, push. It could be like SMS, email. We support webhooks. So if you support webhooks, you pretty much support everything. I think we even have customers sending like physical print media, like mail to people via webhooks, which I think is kind of cool. And so the next part of it, I guess, is that interactive feedback loop, right? So we've sent all this stuff out to people, but we can also track what happens to it. So we can track, are users opening those emails? Are they clicking on those push notifications? Are they eventually making purchases? Are they eventually doing whatever that conversion event you may have defined is? And that feeds right back into the top of the model. The other sort of feedback loop on the left, right? I mentioned how we can send that data out to kind of wherever you want to send it. So We have currents there. You can send things to your data warehouse. You can send it to different integration partners, things like Segment or mParticle. We have a whole host of different places that can go. So it sort of completes the loop of your data flowing into Braze, out of Braze, to your users, from your users. So knowing all that background, let's talk about Braze, the platform monolith. So I said we're going to talk about monoliths and the good and the bad of that. Many critical parts of Braze's platform are part of a Ruby monolith, Ruby on Rails. It's mostly deployed as a Rails application or Sidekick workers, so multiple different ways to run the application, but ultimately it's like one very large Ruby code base. And there's pros and cons to that, but we'll get into that in a bit. Some of those things, you can see a screenshot of our dashboard on the left. We've got a dashboard. That's a very fun, classic Rails application. We have a REST API and an SDK API, like I mentioned, all the devices sending up data all the time. And we have all different kinds of Sidekick workers, these asynchronous job processing workers doing messaging, data processing, maintenance tasks, all kinds of things. Another kind of way to look at that is my very lovely drawing here of a 50,000-foot view. In the dotted line there, you can see this is kind of the monolith part of it. It's the dashboard, the APIs, and Sidekick, which if we drew it to scale is much, much more enormous than all the other things. But all that stuff is Ruby code. It's all the same code base. Outside of that, we have currents, which due to the amount of data that is, it's done with Kafka. A lot of the pieces in that are actually done like Java, so a little bit different. Not part of the thing that I work with day to day. But yeah, that's generally how I think of our software. And so the question that you've got to ask is, how do modern observability tools, work with a monolith like this? If you were to just take the Datadog tracer, like ddtrace-rb, and plug it right in, you're going to get a very detailed service called Sidekick, and then you're going to get another one called Rails. And that's not super distinguishing when you have 15,000 endpoints or something like that. So we'll talk about some ways to improve that. So services bias and modern operational tooling. If you did take this enormous application and plug in the tracing library, you'd end up with effectively 2 services. And that we have a couple dozen engineering teams. We have hundreds of engineers and product managers. There's probably a little bit more than 2 services to the whole concept. But a lot of modern observability tools are built around this idea of, you have a lot of different services, that you may have a very pretty looking service diagram there up on the top right, where a couple things may talk to some other things. The lines are really well drawn, and it's easy to follow and easy to understand. This is good if this, the tools work really well if that's how your architecture is laid out. You can use service-based monitors that work really, really well, right? If you have an authentication service and you add a new endpoint for authentication, if you already have a monitor for that service that says, page this team when something bad happens, it just works for the new endpoint, right, out of the box. If you've got flame graphs of traces, so a trace graph there on the right, you see there's different colors for different services. It's very easy to distinguish, where are we spending all of our time? Network and traffic flow diagrams, also very simple to understand sort of where your high traffic areas. And then AI-based correlation tools, this is actually one of the ones I think is the most interesting, is that when they're provided with a lot of context, all these different pieces, they can actually use that data to make much more well-informed decisions versus, again, if everything is all just sort of one thing, it just thinks your application is broken. And it's yeah, we know, but we might need a little more detail than that. So yeah, the bad, it's kind of the opposite of the good. If service is not a first-class citizen and you're sort of all of your tools, you're going to experience what I call observability soup. So imagine, I mentioned a giant Rails app. If you just plug and play a lot of tooling into it, you end up with something like this, where it's you have a lot of stuff, but a lot of stuff doesn't really mean much. It's not super helpful from a context perspective. So you end up with things your functionality is conflated. Things that are actually very much unrelated may look very related from the perspective of the tool. You'll have a problem that we've had before where different database instances of the same type are conflated. So we have, for instance, multiple different Redis clusters that have different purposes and are used by different teams. And it's not super helpful when the alarm goes off and it says Redis is down. Doesn't really tell you which one, doesn't tell you which team to page. So we decided to just page everybody, and no one loves that. Team ownership becomes fuzzy, source of error is difficult to pinpoint. just some things that aren't so good, things that make these tools less valuable. So to make it more valuable, how do we monitor a monolith like it's made of many services? The first thing we have to do is break it down without refactoring, right? Refactoring may be something that will take a long time, right? It's dangerous. It's something where unless you have the extremely good test coverage, everybody always feels like, oh, this is really risky to do. Unless maybe you're a little more junior and you're like, yeah, we should totally refactor. If you've ever gone through such a project, not nearly as easy, not nearly as pain-free. But we still need to think about our application as if we were going to do that work, right? We need to think about the domain model. We need to think about the operational model. So the approach that we took, it's an alternative approach that we think of it as these different pieces, and then we send that information to Datadog as if it were those different pieces. And what I mean by that is a couple different steps. So the first thing is to identify the different services. So in our case, we first broke down the web application, and we categorized asynchronous work. And this is an ongoing task for us. But we've identified some things like our SDK API. And we have actually multiple of these, right? We have some that are pure ingest APIs. They don't do any, they don't really return anything to the client except for like, thumbs up, got your information. We have other ones that actually will return data back, maybe in-app messages or content cards, some of the channels that our SDK powers. We have our dashboard application. We have our REST API, which is also, again, kind of split into multiple parts. And then we have things inside of other services that really wouldn't even map to something like Sidekick or Rails. So we say liquid templating, for instance. If you've ever used Shopify, you've used Liquid, or Braze or many other companies that use it. We treat that as its own thing because it's a team owns it. It's like a very sort of complex thing, and we want to consider it to be a first-class citizen. The next thing we do after talking about the services or sort of bouncing back and forth between these two are going to be different data stores. We think about how they physically and how they logically differ. So physically differ, right? They may be different clusters, but logically differ, they may be for different purposes. So for instance, we have thousands of customers. We have their user data spread across dozens, if not hundreds, of MongoDB clusters. They may be physically different, but they're logically the same. We think of them as that's a user's database. It may be different physical machines, dealing with an issue at any given point in time. But conceptually, if we see a high amount of traffic on that, on a bunch of users' databases, we know it's logically going to be probably one feature. So different data stores. I kind of mentioned the MongoDB users versus business objects, kind of our primary. We have different types of Redis, like I mentioned. We have ones that are job queues for Sidekick. We have some for distributed locks, all kinds of other purposes. Memcached, we split out into two things. We actually have sidecar instances of Memcached versus cluster-wide instances of Memcached. All kinds of things, actually. If you dig into it, I'm sure you'd find a lot more. And we work iteratively. So like I said, if you dig into it, you'll find a lot more. We do this on a consistent basis. So the teams that I work with, every quarter, we'll go through and we'll say, okay, what are some more things where we can either find things that should be in a service that are still under Sidekick or still under Rails? Do we have any data stores that we want to pull apart or figure out how can we make those things smarter? And the cool thing is that you can do this stuff really iteratively. It's not like some of these large refactoring projects where we say okay, we have to move away from the legacy thing and turn it into microservices. That's usually a very big jump. This has allowed us to do 2 or 3 weeks a quarter, maybe a sprint or two's worth of work, get nice sized chunk of additional functionality, and then move on to other stuff. So our product managers really love that. So what does this breakdown process look like? Let's take a look at an example application. Here we go. So if you go to this is a real site. I made this for this presentation. It is a leftover food marketplace. I polled my friends for what is the dumbest app idea I could think of, and this is what we came up with. It's got a few different features. I actually thought it was kind of funny because we could come up with a few different services that if this was a real thing, it might have. And if you want to see the source code for it at the end, there's a link here. It's also on the last slide. So. But yeah, place to buy and sell leftover food that you don't want. We've got a few different features. We can view all of the leftovers, kind of like if you think of clicking through a market on Craigslist. You can view the things that you've posted, and you can add new things, and you can buy them. So we have a few different pieces of functionality there that we've got to think of from sort of a logical perspective. And then we have major services. We have like a Rails, a web application that's displaying all this stuff. And we have authentication, we have inventory, and we have payment. 3 things that, at a big enough enterprise you would imagine are handled probably by different teams. So going through this thing, the first thing we do, right, is we add the tracing library. So I just followed the Python tutorial for this and added ddtrace_run in front of everything. If you've never seen a file like this before, the app's running on Heroku. It's like super easy for a demo project. So if you do end up cloning this, you can download the source code and run it yourself if you'd like to play with it. So once you do this, you get a few things right out of the box, right? So if you look at the services list or the services map, you'll find Django, Postgres. You'll find a couple things for Celery. Celery is very similar to Sidekick, asynchronous work processor if you've never used it before, and Redis, which I believe is being used as the job queue. If you click into Django, you'll see on the right, you'll get all the resources. And this is funny. This is actually how, before we took this approach, what it looked like at Braze when you looked at our dashboard. It was sort of a mishmash of everything. Our list here only has maybe 10 things in it. Our list at Braze had maybe several thousand things in it. So this one's much more manageable for us to do. So we'll do this together. So first, let's break down our web services, breaking some of that stuff down. So the first thing that I did is I said, well, I want to make this easy on myself, so I'll make sort of some syntactical sugar. And you don't necessarily have to understand this whole code, but again, it's on GitHub if you want to read it. What I wanted to do was create a method decorator or some similar concept where I could just say, this view is for this service. And if you've used Rails or you've used Django, you know that those have a urls.py or a routes.rb file where you're basically saying this URL goes with this view function, this controller. And so I just want to be able to annotate in that file, this is for this service, this is for that service. And so this helps us out with that. And once I have that, you can see I've got inventory app and payment app, 2 things at the top. I used the partial currying function to make it even less stuff to type out, and added it to a bunch of my different paths in the urls.py file. So you can see I labeled half a dozen of them as the inventory app, and one of them at the bottom, the purchase link, as the payment app. So when I do it and I deploy it and I click through the website a bunch of times, I end up with inventory and payment as actual applications showing up in Datadog. But the code base is still the same, right? It's still like a monolith. It's still one Python code base. A couple more things left. So I noticed that I still had Django as a root level thing there. And I was like, oh, I thought I got rid of everything. I didn't. I actually had not done the login links, log out, and all that stuff. And I'd actually been using the admin panel. If you've ever used Django, it has a super nice baked-in admin. I was using that to play around with some stuff. And so I said, well, let's just call that an app as well. Because those things use a list of URLs, I had to do a little more trickery. I found this nice decorator include that basically just applies the same method decorator to a list of stuff. Go open source. It's always nice to find a solution to your problems and not have to write it yourself. And I added 2 more things, admin app and auth app, and put those down there in the URL patterns as well. Once I did that, and I let it run for a little while, and even the icons changed to the web icon because it recognized, oh, these are all view functions. I was able to split everything out. So I no longer even had something called Django inside of my services. Despite it being a Django app, I actually had payment, auth, admin, inventory. It all showed up as separate things. So now I can make monitors, I can make SLOs, I can create all these things that are first-class citizens in Datadog, and link them against these services that aren't really different services. Makes the tool a lot more effective. So back to the real world on this one. So Braze is accessed in a lot of different ways from the web. I mentioned earlier, REST API, SDK API, dashboard, lots of different integrations. And from all over the world as well. We've got all these different web services, and we're kind of slowly in the process of breaking these things down. We've got our dashboard, which actually, because of the amount of functionality, we may break down even further, right? We have 20 teams that own different functionality on the dashboard. We have internal tools. We have multiple kinds of APIs. We have bulk ingestion endpoints where service providers, like email service providers, send us click events, things like that. We treat those all as services. So they all show up as different things inside of Datadog, and we can have the alerting and the alarms going to different teams. We can track SLOs differently, all that good stuff. So now let's break down our async services, right? I talked about Celery. Braze uses Sidekick, same idea. Actually, the function, or rather method decorator that I wrote worked just fine without changing anything, which was pretty fun. So I was able to use the same thing on my very complicated complete purchase function there. And I just decided to name it payment async so that I'd have something different. Oh, there we go. You can see that guy. And once we did that, we saw that show up as well instead of being celery worker, right? Which is something that, like, we know it does something async, but we don't know what it does. It shows up as payment async, so we have a little bit more context, right? It's easier to go through that service list and see, oh, like this one's on fire. It's not just question mark, it's the asynchronous payment service, so someone should probably get on that if that's the case, right? So back to the real world, most of Braze's workload is actually done via asynchronous processes, and a lot of that's done with Sidekick. We do want to split it up more someday. We actually want to split it up, a lot of this work up into individual services. These things, the workloads like scale very differently. So it's definitely like a thing we'd love to do at some point. But today, what we can do is apply this process, and we have done that to some degree. We have things split out. So again, it's not just Sidekick. We have message sending as its own sort of group. We have Canvas, right? This thing I mentioned is like a workflow engine. Think Lucid chart, but users actually move through the flowcharts. We have data ingestion, maintenance, reporting, all kinds of different things that are isolated as their own services. And again, it makes things just a lot easier to track from within the UI. So how about data stores? Our application where people are storing all their leftovers, maybe their sessions, stuff like that. We'll skip that with our example app, but we'll talk about it. This app's not so complicated. If it's, I think there's 3 tables in it, so probably not worth splitting out. But at Braze, we have all kinds of different databases. We have NoSQL, we have SQL, we have key value stores, the whole gamut. And we have a bunch of different business objects, like campaigns, canvases, segments, companies, app groups, all this fun stuff. And we also have users. So I mentioned earlier, right? We have like thousands of customers, and their user information is spread across hundreds of databases. And so those things we've split up as the first couple things in that list, right? MongoDB users, MongoDB business objects. It's an easy way to kind of logically split out those things, despite the fact that physically users really is going to look something more like that on the left, where you've got hundreds of different databases for different things. We've also got different, like I said, the different Redis instances, different memcached instances, Postgres instances, all that good stuff. So a lot of that stuff is actually done either by adding custom spans, and then sometimes for some drivers you can say, if it's this URL, like a connection string, then call it this type of Redis, or if it's that URL type, call it this type of Postgres. The support for that is actually pretty good from what I found in all the different tracing libraries. So yeah, my kind of big takeaway from all this is refactor to services iteratively, but start with observability. It's actually really easy to do this. You can do it piece by piece. And as you're doing it, you might figure out that your original domain model or your operational model that you were thinking of doesn't really make a lot of sense. And it turns out it's way easier to just move around some spans and resources and stuff in Datadog than it is to refactor your application yet another time. So great way to start doing that is to start with observability. Any questions or anything?
All right.
I think we've got a cool...
we do, yeah. So we do have the Catchbox microphone here. So the only request here is that you speak directly into the microphone. It doesn't pick up very well. Also, the room is very echoey, so take your time asking questions because it's a little hard to hear up there.
Hello, hello. Hi. Hi, first of all, thanks for sharing. I mean, monoliths, they usually have this vibe of being like legacy code. So this kind of worms from whenever and no one really wants to touch it, at least not now. I guess you were in the same situation. Could you think of a valid scenario where like today someone would think, hey, let's make this a monolith to, I don't know, reduce communication overhead or whatever, and maybe then like logically break it down in the way that you did? Or would you just say, no, microservices the way to go, all the way?
Could you repeat the kind of last part? I'm sorry, I've got a bit of a cold.
It's hard for me to hear. I guess the question is, so what you basically presented was like how to deal with a legacy application, which is a monolith. And I guess ultimately your goal would be to break this down into microservices, but you don't have the time or capacity for that now. But at least for your observability, you basically broke it down logically. So you have different types in Datadog, etc. And my question would be, would there be like a valid scenario where you would think today, 2023, I'm going to make a monolith application, maybe break it down logically the way you did it, but could there be also like advantages to that, like less communication overhead between the services? I think there's also this microlith concept where you like group things that belong to the same domain together into one semi-big applications. I guess more like a philosophical questions if monoliths are could still be a thing today.
Yeah, no worries. So I'm going to try to answer that. I think I understood. So if I guess maybe I'll start with like the application kind of in question, right? And the way that this came up is less that we were trying to say, here's a legacy monolith that we don't want to refactor, as much as like this is like Braze is like live, living, breathing code that 200 plus engineers work on every day. It is a Ruby monolith. It's the fact of life, and we know that a lot of the concepts are coupled together in such a way that like we know even if we did want to pull things apart into services, it's an extremely expensive thing for us to do. And so I think maybe kind of taking that, and this is my understanding of your question, say you're in a different scenario where you're doing more greenfield stuff. I think you were saying like, if would you choose to build like just start with the microservices, or maybe like save some time at the beginning and build a monolith, but then like always be observing it that way? Was that kind of the direction of the question?
Yeah, let's say I have a greenfield project, and I think intuitively I would say, okay, how can I split this up into microservices, and how do they communicate with each other? But would it be like completely insane to think today, no, I'm going to do a monolith, like it's not like this functionality of like these 3 services, I could merge this into one thing, basically.
Yeah, it's definitely something from, so I've worked at a bunch of different startups from, like the 1 to 5 person range, and I know not to start that way. I've seen it go bad enough times. I actually used to do consulting when I lived in Nashville, and would do the opposite. I'd go find companies that started with microservices and charge them a lot of money to put them back together. And it ends up causing a lot of friction early on. So, if you really are sort of glued to the idea of like, I will have microservices at some point, but maybe my engineering team is not large enough to be able to really support that right now. To your point, I don't have like a platform, engineering team that can support it. Then yeah, using the strategy, kind of starting from a greenfield project, may very well be a good idea to set yourself up for success in the future.
Thanks, Zach. This was really useful. Trying to figure out a way to formulate this question. Y'all work in a Rails app. I work in a Rails app. I want to go try to do this tomorrow when I'm recouping from my conference. So I guess there's 2 parts of this. One, this is a Python app. Cool. Is there a community of practice where people are talking about this, where there's already kind of like macros or existing helper functions that people have written, so that someone who is aware of their app, but will say like a junior-ish non-staff engineer, can actually start doing this without needing to figure out how to write a proper decorator in their language if that's a pattern they're unfamiliar with?
Yeah. So I'm going to rephrase the question. It's a little echoey, so I'm trying to rephrase the question to make sure I heard you right. Is if you wanted to go start doing this tomorrow, are there resources out there? Like, is this sort of easy enough that somebody that more junior or somebody that has not done something like this before would like easily be able to go and do it?
Almost more, is there a recipe book?
Is there a recipe book for it? Got it. So not that I'm aware of. It was actually something that sort of came up organically for us, as again we'd click into the services and the resource lists and be like, this isn't super helpful because it's like gigantic. And so the first thing that we did was say, okay, well, let's at least get a few of these things separated out. We went to the docs for the tracer, and we saw like, oh, like you can, we found the data store thing first actually. We said, oh, like I can make specific URLs show up as different things. Like that's at least helpful. So we started there. And then once we started doing that and we saw all of a sudden, like instead of Redis is on fire, it was like this specific Redis is on fire for this specific reason. And we got the benefits out of that. We started to ask ourselves like, oh, like what else could we do to make things look like that? So it's less of a recipe and more of sort of a homegrown solution to a problem.
Hi, I had a question. How do you manage infrastructure metrics with that approach? Like if you have like in a traditional microservice sprawl, you have like a service per host or per pod. What kind of challenges did you run into if you're managing infrastructure metrics?
Yeah, that's a good question. And it's actually something really like pertinent. On my flight here, I was actually working on something similar to that. So I'll give you kind of the example of a question we're still trying to figure out exactly how to do. So we have like workers deployed that have all kinds of crazy sort of different configurations they can be in. So we have workers that'll only work on message sending. We have workers that'll only work on data processing. But those are still like dozens of jobs, and they actually may span a bunch of different teams, right? I have like data processing that's like email events coming in that our email infrastructure team owns, but I also have data ingestion events coming from like SDKs, which a different team owns, that sort of thing. And so then it's hard to say, I've got this like Kubernetes pod that's running Sidekick, and it's doing all these events, but it's for different teams, and they show up as different services ultimately in Datadog. So we're actually trying to figure out, what's the best way to do accounting for that? One of the things that we've been tinkering with is playing with like middleware. So Sidekick has middleware, right? You can kind of hook into it before any job is run. And then we just add our own custom metrics to things there. So we'll just do counters of like, if I know when the job started and the job ended, I can time it. So then we'll just like send timings that are segmented by like job name or by team name or whatever. And then it's got the host name in it, by default. So like I can tell, on a per host basis, like 30% of that host's CPU time is spent by this team or is spent by this service, this function, something like that. We're trying to figure it out. It's not perfect yet, but it's working so far. So
thank you.
Yeah.
Okay. Well, in the absence of that, again, Zach, thank you so much for sharing your story with us. Everyone, big round of applause.
Yeah, thank you.